Yeah, so hello everyone once again, and greetings from London. Thanks for amazing introduction, and also thanks Daniel and Santiago for great presentations. I really enjoyed listening to it, and I think my presentation was well introduced by Daniel, who described also some data shift problems in his presentation. And yeah, it's my pleasure to have you all here, and thanks for the invitation for all organizational team. So I would like to present Popmon as something that we have developed internally at ING, and it was very useful for us. Therefore, we would love to share this with the community. As you can already imagine, Popmon stands for population monitoring, and population shift monitoring could be also called as a covariate shift problem, which looks into data shift problem, which I'll elaborate in this presentation. So first, for words about me, Sam already introduced me, but I'll just give a brief introduction. So I'm a data scientist at ING, namely Wholesale Bank Advanced Analytics. I've been at ING for 1.5 years, and the first half of the career I've been focusing on the data shift monitoring problem. And as an outcome of this, we have developed a package, which we have open sourced recently in April. So if you have any questions or any feedback after the presentation, feel free to reach out to me. And here you can also see the presentation outline. We're going to talk about motivation, why we started this, and the problems we have bumped into our solution. We're going to jump into demo and show the use case within ING that we use this on. So initially at ING, we have observed this, that our models, our machine learning models and data were not being monitored carefully enough. And after looking into open source solutions available, we didn't find anything that would completely suit our needs. And since we had some past experience in doing this right, we have decided why not to do it ourselves and build something suitable for our needs. And why is this important is because we want to run reliable and consistent models in production. We want to be sure that newly incoming data and predictions are consistent with the trained data on which model has been trained and tested initially. Because if input features change over time, then we cannot guarantee that test performance will be the same as intended. And also it's good for reporting purposes. So for example, for audit, if anyone's going to check your data quality, how it was a year ago, it's always good to have a paper trail of this and keep a log of your data quality, especially if you work in such a regulated industry as banking. Some common issues that can be seen when working with data are population shift, data rot, and time dependencies. So population shift is when features are changing over time. So feature distributions, for example, as we'll see also later. Also data rot, so when model is being trained on the one data, but it's not relevant anymore for the predictions. So basically, the data changes over time, and the previous data becomes irrelevant for the new model anymore. Also, the time dependencies. So, for example, you can observe that some data is seasonal. So, for example, you have spikes in data at the end of the month, and you would like maybe to take this into consideration when training your model. Yeah, so when building a solution, we have identified 3 types of monitoring, namely data, predictions, and model performance monitoring. So if we look at the open source community now currently, there are quite some solutions for model performance monitoring, namely Seldon and MLflow. However, if you look at the data and predictions monitoring, it's quite lacking. Those 2 solutions are providing some kind of data monitoring. However, it's not sufficient because they're tracking only mean and standard deviation of the data. And let me show you why is that not enough, just tracking those basic profiles of the data. So if you look at this plot here, if you look specifically at the data points, you can see that data points are moving over time. However, if you look only at the data profile, you see that the mean and standard deviation, which is here represented in this box plot, are not changing over time. If you look at the histogram, which represents the distribution of this data, you can obviously see that it's very different. It differs a lot over time. So if you would be tracking only mean and standard deviation in this way, you wouldn't be able to see the change in data. Another example is if you look at the 2-day data, you can see that the mean and standard deviation for both axes doesn't change. However, if we look at the histograms of the same data, you can see that it changes quite a lot. So if we would be tracking only those basic statistics, we wouldn't see basically a data shift in this case. So histograms help here a lot. And another good example is, for example, if our trained data has one distribution, which you can see here in blue, we build model on this, and then we want to basically predict a new incoming data, which in this case is test data. If we apply exactly the same model on the test data, it's probably not going to perform as we have expected because the distribution is completely different. And this is fine if you look at this. It's fine to inspect it visually because in this case we have 1 or 2 dimensions. But imagine if you have way more dimensions and you have a lot of features to take into account. So you would like probably to have this. You would like to detect these shifts automatically, and then all these on all of these features at once, or even better to have it scheduled somewhere and be done automatically, and you would just get alerts once in a while if your data is not behaving as expected. So we have developed a Popmon package for this, and I'll just explain very briefly how it works in a very generic way. So we have incoming data, which is here represented as new data. It's a raw data, could be CSV, pandas, whatever. You convert this data into histograms. And ideally, which in this case is test data, so your incoming data, and ideally you would have a reference data, which is your trained data. And you would compare how this incoming data, how similar it is, or how does the distribution compares to the train or reference data. And based on that, you compute a bunch of metrics with statistical comparison methods. And based on thresholds that you impose, you basically would like to alert if your neural data is much more different from the reference or trained data. Yeah, you don't necessarily have to have reference data. You could also compare to the incoming data. So for example, the same incoming data, test data. If you have data coming, for example, in a batch of 1 year, for example, you could split the same data per week or per specific period, let's say per month, and you could compare data to itself. So let's say each week you would compare to the previous week. So in this case, we split 1 year into 52 weeks. And we take consequent weeks. So like week 1, week 2, we can see that distributions are quite different. If we overlay them on top of each other, we can see that even better. And then we can visually see that those histograms are different, but we, as I already explained before, we would like to have it to be done in a more automatic way. And how do we measure this difference? How do we make it more tangible? So we apply a bunch of statistical tests. So in this case, chi-squared, Kolmogorov-Smirnov, Pearson's correlation. We have much more tests, and with the help of Popmon package, you can implement your own tests very easily because you have an interface of histograms, and basically you can apply any of your favorite tests on those histograms on the data you get. And also, yeah, we get the same data profiles if you're interested in described before, the mean standard deviation and the others. And you would ask why histograms? Why do we use histograms? Histograms are very useful because it keeps aggregated information. So we don't keep any raw data, which is very good for data privacy and confidentiality. So yeah, we don't have any raw data, so we don't get in trouble with the privacy issues. Also, it's good because size is more minimal, so it's easier to store. And also light for sending over APIs. So let's say you want to have a client and the server, for example, running Popmon on server. It's way easier just to aggregate this data into histograms on the client side and send it over the API. You don't have to send gigabytes of data. Way easier and way faster. And also, once again, you avoid data privacy issues. Also, monitoring works identically with both big and small data, because if you have more data rows, which is basically is being aggregated in the bin count, you don't get many more rows if you would be storing, for example, a table. And also, histograms are more visual, so it adds information automatically. So, for example, you can just observe the distribution, and it gives you a lot of information immediately. Because if you would be looking just into raw data in the table, that would be difficult to notice any obvious patterns in data. And also, as could be seen from before, it's very useful for applying all sorts of statistical tests. Also, within the Popmon, we have a so-called concept traffic lights, which is basically if our data falls into a green zone, it's all good. Yellow, we need to take care of it. And red, something is really outlying, and basically we have to immediately take a look at it. And we have implemented two ways of looking at it. One is a static way. So basically, you can define those traffic lights in a more static way. So let's say if data falls into a range of, for example, between value for some feature between 10 and 100, you alert and you want to, check the data. But what we also thought is when we have a lot of features, it's a bit hectic to define these, static traffic light bounds for each of the features, and especially if there is a population shift, so data is changing over time. Maybe you want your data to allow to shift a little bit, depending on your reference data. And so we came up with a more dynamic traffic light rules, which is based on standard score. So what we do, we compare each bin to the reference data. If you look at the formula for the standard score, we compare each bin to the expected value for that distribution, and we divide by standard deviation of that distribution. So in this case, you can see on the right plot that we compute the z-score for each bin, and based on our configurable traffic light bounds, which is here, everything what's below -2 or above 2 is red, and everything was below -1 and above 1 is yellow. So everything what falls into those, you would like to look at it. However, just for this demonstration purpose, we set these traffic light bounds so low. So this data is not so outlying, but for demonstration purposes, we set the traffic light bounds low to see that it actually outlies. But usually, with the sensible traffic light bounds would be something between -7, -4, 4, and 7. So let's look at a more concrete case. So in this, in here, we basically, if you look at the right plot, here you can see medians for each week, or for example, for a year of data. So as the first bin represents the median for the week 1 for a specific feature. And here you can see how the median was changing over the year for that specific feature. And yeah, if we take this as a reference data, we can compute the mean value and standard deviation of this basically distribution, and apply this on the newly incoming data. So once again, by computing the z standard score, we can apply these traffic light bounds and see what is outlying on the new unseen test data. And the reference also can be chosen as we already seen in the previous example. So we could compare it to reference data, which is the trained data. You can also compare it to self. So let's say we don't have any trained data, but we have a lot of incoming data, and say we get it for a year. So we'd like to compare each week to the full year. You could also do this the sliding. So for example, as we saw in the previous example, we were comparing each week to the previous week. We could say we compare 1 week to an average of last 10 weeks. So then we would have a rolling or sliding window. There's also expanding window. So compared to everything what happened in the past. So different traffic light comparisons are available here. We also have a prediction monitoring, which could be basically reduced to a data monitoring problem if you for example, convert your probabilities, which is the output of your model, and you could track the distribution of those probabilities and see if the probability distributions are changing on your new unseen data. So, for example, if you in a bank, if you expect some part of companies going to default each month, let's say, and you track this distribution every month, if something is changing, if something has changed in your data distribution, for example, in this month in comparison to the previous month, you would like to check, you would like to see what happened in the data. Maybe there was some cleanup or something that was done from the business side, and maybe you would like to retrain your model because something has changed. Your model start evaluating your data in a bit different way. So once again, our package is not only for data scientists, it's also very valuable for data engineers. So for data scientists, it's great for data exploration. You can see data patterns, seasonality, you can find outliers, trends in data. It's also very valuable for early inspection of covariate shifts. But also for data engineers, it's very valuable because it allows to build data ingestion pipelines. So basically monitoring the incoming data to prevent drop in performance of your model. Also, stitching is available. So, for example, you have already some data that already is stored within this package, and then new data is incoming, for example, in batches, so over a certain period. So let's say we get new data coming in weeks, or let's say in a bunch of records. When you get 1,000 records, it's being stitched into this previous data and being compared to that data which is already in the pipeline, which is very useful because then you can see if this new data is outlying from the data that was seen before. Yeah, so from boring theoretical talk, let's maybe dive deeper into the code itself and see how easy it is to run a Popmon. So almost no initial configuration is needed. What you need is basically your data set. So in this case, we're using Pandas data frame. Spark data frame could be also used in this case. And what we do is we basically import our package. And by importing the Popmon, it extends the functionality of Pandas data frame. And it extends it with the function, in this case specifically, PM stability report, which you can call later directly on the data frame. And as an output of this function, you get the report, which can be run directly in Jupyter Cell, which we'll show you in the demo. And you can even have it simpler. So if you have already your data frame ready, Pandas data frame, once again, you import your package, import Popmon package, and apply the same function. And also you can, by adding another function to file, you can easily store it in an HTML file and open it anytime on your laptop without need to run it in Jupyter Notebooks. And yeah, no internet traffic is also required because yeah, all the JavaScript files that are needed to run this report are being stored in this file. So let's jump right into the demo. I'll show you the report that we get as an output from the Popmon. So here I've been using a Kaggle dataset, Kaggle flight dataset of the US in 2015, which has a bunch of different features like airtime for different flights, whether the flight was canceled, departure delayed, and these type of features. I have a subset of features that I've created myself. And to understand these plots, you can see that this is going from left to right. So this is all data for 2015. So we bin this data per 2 weeks. And basically we get, in this case, we see profiles. So in this case, we can see how many flights there were per that specific period. So in this case, per 2 weeks. So here we're looking at the feature airtime. And then we can see that, for example, on average, flights in different 2-week periods were around 120 minutes. Then you can also look at other features. Maybe something that would be a bit more interesting for us is the cancellations. So how many flights have been canceled during that period? And we can see that there were some spikes in the beginning of the year and the end of the year, which makes sense because that's a winter period, and there were way more cancellations if you compare it to the reference data. So you could see it is already outlying because it goes above the yellow and even red line for some of the 2 weeks. So these are the basic data profiles. We can also look at the comparisons, basically those statistical test comparisons. And we can see here a bunch of statistical tests that were described before, chi-squared, Pearson correlation. And if we look specifically at cancellations, we can see again some spikes in the beginning of the end of the year. If you feel like this is overwhelming to look at all these statistics, you can add these statistical tests yourself. You can also remove some of them because it might be too much. You can also look at aggregated features. So for example, here, aggregated traffic lights for those features. So if you look here at the canceled feature, you can see traffic lights for those specific time bits. So you can immediately zoom in and see like that there were a lot of outlying. Once again, our traffic light bounds are very liberal in this case. That's why we get a lot of red and yellow lights. But just for the demonstration purposes, you can set them as strict as you want. And then you have even more aggregation. So for example, here we have alerts for all the features without need to zoom in into specific metrics. We get all the green traffic lights for the specific feature. Let's look at again the canceled. We get all the green lights, all the red lights. We had 6 spike again in the same time bin, which was where we had a lot of cancellations. And then yeah, we can also look at the histograms of the specific feature. So in this case, we were looking at the flight data. So we have different airlines, the most popular airlines within in the USA. And then we can see how this data was changing. So the current week for this date, you compare it to the previous week and also to the reference data, which is basically different colors here. And how you might ask, how do you make this report yourself? So basically, in our GitHub repository, we have a tutorial. So in this case, you can click here, open in Collab. So you don't even have to set up your own environment. And here we are running this in Google Colab. I already ran this, so we save a little bit of time here. Basically, as explained before, we import the Popmon package. We get some data, so some test data here, which is some random fake data, like with random features such as age, balance, company, etc. And then we apply basically this Popmon function on this data frame. We add some configuration, which is all described in the documentation for the package. But these are usually the most needed configuration settings, such as the time axis in your data, which can be also inferred automatically. We have also the time binning, so you can say every 2 weeks, every 1 week, every month. You can set it yourself. And also the features that you're interested in. Maybe you're not interested in the whole data frame, so basically you can specify here what you're interested in. You're getting report here directly in the Jupyter notebooks, very easy. But if you don't want to get the whole report, maybe you're just interested in the raw metrics itself, we're storing here the whole intermediate state. So basically you can see different tables, the pandas tables, data frames, which are storing this intermediate information. Specifically here, as you can see, the profiles page, you can get exactly the same features and metrics. If you look at this profiles key, and then you list keys, you get different features of the data, and then you can zoom in on specific feature of the data, in this case age, and get specific metrics for that feature, which was a mean standard deviation. And if you don't want to print the whole report, you can basically just print your own, you can plot your own plots as easy as this, just by using the computations that we have done with our package. So basically that's it from the demo perspective. You can also build your own more complicated pipelines. So in this case, we showed something that's maybe less customizable, but easy to use and out of the box. And yeah, you might be wondering, how do I create one myself, and how do I add maybe more custom functions to it? So in this case, on the top, you can see the modules that we import. We also initialize some configuration. Here you can see monitoring rules. So you can really do granular, you can define those monitoring rules in a granular way. You also, as also described before, you have a data store intermediate state. So in this case, it stores the outputs and inputs of the modules, which are important on top. And then we have a list of modules in the middle, which is basically here HisSplitter, which splits the whole year of data, for example, into weeks. Then we get HisProfiler, so it profiles those separate weeks into gets the statistics of those weeks. Then we create a section, which is in this case called profiles, and create a report with report generator. So in this case, this is very simple pipeline. So we would get only one section, which we do call profiles. And then in a scikit way, we run this pipeline and get the output, the report. And we can print the stability report in JupyterCell. I also promised to explain one of the internal use cases that we had within ING. So here you can see one of the metrics that we can see that we could see in the report, which is chi-squared. And here the feature was being compared every week to the previous week, and we were comparing different metrics. So in this case, I think it was count, and we could see or mean, and you could see in this case that there was a spike in September 2018. And after applying Popmon, we have noticed this, and we started addressing this. So we went to a data owner and asked what happened with the data. And apparently, after doing some investigation, we were told that the data source has been switched to a new data source. And when doing some tests, we have noticed that training our model on all data has a lower performance than training only on this new incoming data, the data from that point. So after doing some experiments, we have decided to use only the new data, and our training training on the new data gave us way better performance. So this was a very good insight just by applying Popmon and on the data that we were using to train that model. So we have managed to improve the model performance without doing much of the feature engineering. So a short summary once again about Popmon. Yeah, we got it released in April 2020. Yeah, you should use Popmon to monitor the stability of a pandas or Spark dataset. It helps you automatically detect changes over time. Also alert based on static or dynamic business rules. It's very easy to extend. You can make your own data pipelines, as were presented before. You can add your implemented statistical tests, and they'll automatically show up in the report. Here I was focusing more on the 1D histograms, but 2D histograms are also possible. So yeah, feel free to play with it. And what future holds for us, as you can see, this is almost the end. So since there is a little delay in the presentation, it's time to ask questions. So the integration, what future holds for us in this case, we would like to integrate this with Amundsen, which is the data discovery platform, which was developed at Lyft, but in collaboration currently with ING. And by using Amundsen, we would like to use this on ING data quality pipelines. So, for example, we would be tracking all these, data changes over time automatically on our ingested data, which would be very powerful. And we also, since we recently open sourced, a lot of new features are coming up, and we are open for ideas and contributions. So, for example, one of the features that we are adding now is this temporal view of the histogram. So as you can see here on the bottom, we would like to represent histogram change over time, where the color is a bin count, and how those bin counts are changing over time, which in this visual way you could see, for example, for the whole year of data very easily just by changing color, how those values were changing. and this provides a good aggregated view on one feature over time. So we are adding these type of features, and we have much more ideas which should soon appear in the report. And we would also like to integrate this with our other packages such as Airflow and MLflow. Airflow specifically, so for example, we would have these reports being generated on the scheduled basis, or let's say every week or every 2 weeks, once again, depending how do you bin your data. And yeah, so that's it. And I have a question for you. Are you ready to give your data the attention it deserves? Thank you very much.
Yeah, so thanks a lot, Thomas, for your very nice presentation. And you got some compliments on your super nice slides. So in the chat, we had already Q&A going on because Dan was asking, do you have any plans to add extra statistical tests? One of our colleagues, Max, already explained that you already have multiple, which one you're thinking about, and Dan is just wondering. So can you elaborate on that? So do you have any plans to add extra statistical tests, etc.?
So the way we have done it, we have done it in like we have done the implementation in such a way that users can add these statistical tests in a very easy way. So far we have implemented the Kolmogorov, Smirnov, and chi-squared tests, and there are also quite some tests on the agenda, but yeah, we haven't prioritized yet. So I don't know if I can elaborate on this, but yeah, I guess maybe Max answered regarding this. I don't see the questions.
Yeah. Okay, thanks. Then we have a question from Feng Yun. Which tool do you use for your UI? Do you provide microservice for ING internal use?
So currently, we are generating these reports, which are HTML reports. So JavaScript is being used in the background. So basically, this file, as you can see here, it runs as a whole. It has HTML, JavaScript, and CSS. So if you're aware, within ING, we also have that platform, which runs Jupyter Lab notebooks. So since the output of this report is HTML file, it can be opened directly in the browser there. Also open Jupyter Lab cell. So yeah, basically it could be served and opened in any platform which supports browser view, I would say.
Okay, thanks. Then we have a question from Tim. So thanks for the talk and all the work on Popmon. Can you share a little bit more on the vision roadmap? For example, are there any plans for integrations with other libraries or for interactive plots?
So maybe on this plan in the future, because as we described, this is focusing on data monitoring. But I also described in the beginning that we would like to do performance monitoring. So we were looking how to integrate this with other packages such as Seldon and MLflow, which also look into model performance and deploying models. So we will be looking into the integration with that. Also, as I described, also in the future plans, it would be nice to combine this into Airflow DAGs, so make it an easy way for user to run this in a scheduled manner. So these are some of the initial plans, and also we have some visualization plans for the histograms themselves. As I showed in the report, and on the bottom we saw histograms, but it was a quite limited view because you can fit that many histograms in one plot to make it not understandable anymore. So we're looking into more creative ways how to show this. So also in this, what I showed, this more temporal view with a lot of changing colors. So we would represent the histogram over time. So not in the basically 1D manner, but more 2D with the temporal axis, and by displaying different colors showing different bin counts, as I showed in this future slide. So we have different ideas for visualization as well. Yeah, basically we have a lot of ideas, limited time. So we are calling everyone to contribute. We would be very happy to share those ideas, and yeah, feel free to join.
Okay, thanks. Thank you. I think we have one last question from Jesse. What about non-numerical data? Does Popmon support that? Or do you first need to convert it into numerical features? We are building topic models, and we have a problem we face is when the new topics pop up.
So as I showed also in the demo, we had some also non-numerical features, like was categorical, so basically airline name. So that also works with the categorical features. Yes, it's let's put it in this way. So you can get more metrics and more basically more statistical tests on the numerical features. But yes, we support categorical features as well. Yeah.
Okay, thanks.
One more question.
Okay, no, Tim said I asked a question before your slide on future. So thanks for elaborating, Thomas.
Cool.
So I think this was it.